This lesson is on measuring angles. So let's get started. An angle is formed by two rays, so ray BT and ray BQ, and those two rays come together at a common endpoint called the vertex. So ray BT and ray BQ, they come together at this point B, which is called the vertex. Okay, we have several ways of naming an angle. One way is to just name it by whatever the vertex is. So I can call it angle B. But that doesn't always work, and I'll show you why here in a minute. Another way is to use three different letters. So you have to make sure that you use the vertex as the middle letter. So I can call this angle TBQ, making sure that I used the vertex as the middle letter. I could switch that around and call it angle QBT, making sure that I use the vertex as the middle letter. And in this picture, we have something special. We have just a number in the center of the angle, so I can call that angle 1 as well. So a few different choices we have. Okay. Down here it says you cannot name an angle just by its vertex if the point is the vertex of more than one angle. So let me show you what that means. This angle right here has B as a vertex. Well, this angle right here also has B as a vertex because these two rays come together at B. So if I said, where's angle B? We don't know. Are you talking about this being angle B? Are you talking about this little one being angle B? Or are you talking about this big angle being angle B? We don't know. So if the vertex is the vertex of more than one angle, you can't just simply call the angle by the vertex name anymore. I can't just call it angle B. So that's a no-no. It doesn't work for this. Okay. So let's try to name this one I colored in red here. So remember, we have to have the vertex as the middle letter. So I'm going to call it angle ABC, making sure that my vertex is the middle letter. And I could have switched it around and called it angle CBA, but that means the same thing. How about the one in green? I could call that angle CBE. Or it could have been EBC. And then we also have this big guy. What can I call this whole big angle here? Angle ABE. Or those letters could have been switched around, EBA. But we have to make sure that the vertex, where the two rays come together, that vertex is the middle letter. Okay. This little M right here stands for measure. So I read this. The measure of angle A is 60 degrees. And I've written that off to the side for you. The measure of angle A is 60 degrees. Okay, these terms down here, they should look familiar to you. An acute angle is something that's less than 90 degrees, but bigger than 0. A right angle is exactly 90 degrees, and to know if something's exactly 90 degrees, you will typically see a right angle box. So if I drew an angle like this, and you don't see a little box right here, it may look like it's 90, but we don't know that it's 90, and we can't assume that it's 90 unless something has told us that it is. So in order for an angle to be a 90-degree angle, we'll have to know something, and this little right angle box shows us that it's exactly 90 degrees, and that makes a right angle. Okay, an obtuse angle, this is an angle that is bigger than 90 degrees, but not quite a straight line. So it's somewhere between 90 and 180 degrees. And then we have our straight angle that makes a straight line, and that's 180 degrees. From here to here, that's 180 degrees. And the reason it's 180 degrees is because all the way around a circle is 360 degrees. So if I only go halfway around the circle, then that would be 180 degrees. And that's what we do right here. We go halfway around a circle. We don't go the whole way. So a straight angle, or you can think of it as a straight line, it's 180 degrees from here to here. Okay, the word congruent. We talked about this the other day, but with segments. So you can see down here, these two angles are both 74 degrees, which means they're congruent. So we use curves to show congruent with angles. We use tick marks for segments. If these two segments are congruent, they get tick marks. If these two segments are congruent, they get tick marks. With angles, we give them curves. So if I give them both one curve, they're congruent. If I give them both two curves, these two angles are congruent. I could give them both three curves, etc., and that shows they're congruent. So the measure of angle CBA equals the measure of angle DFB. And if the measure of the two angles are equal, then that means the two angles are congruent. So angle CBA is congruent to angle DFB. And if you can't see that symbol well enough, or if you forgot from the other day, remember congruent looks like this right here. Okay. The next thing on our list is the angle addition postulate. Little plus little equals big. We saw that the other day, but with segments instead. So let me show you what I mean. Let's say I say this angle right here, angle AOB, is 80 degrees. And let's say I say that this angle right here, BOC, is 40 degrees. How much would this whole big angle, AOC, be? How much is this whole big angle from here to here? 120. And that's because this little angle plus this little angle equals the whole big angle. Little plus little equals big. That's called the angle addition postulate. Okay, in this picture, I know that angle AOC here is a straight angle. It makes a straight line. So how far did we say it was from here to here? 180 degrees, because that's halfway around a circle. So anytime you have a straight line, a straight angle, it's 180 degrees from here to here. So let's just say that this angle right here is, I'll just go 80 degrees. If this angle right here is 80, what would this angle right here be, BOC? It'd have to be 100, because these two angles have to add up to be the total, and I know that the total of a straight angle of a straight line is 180 degrees. Little plus little equals big. Okay, let's look at an example together. First one says measure of angle RST is 50. RST. First I need to find this angle. RST. RST. I know they're talking about this angle right here, and they say it's 50, and it's actually marked, so that's great. Next I need to find this angle. RSW. 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 This time they're talking about this whole big angle, all the way from here to here. And they say that that's 125. The question is, what's the measure of angle TSW? TSW. TSW. That's this little angle right here. TSW. So what would this little angle be right there? It would be 75 degrees, because this little one plus this little one has to equal the big, and the big's 125. And we can always get that by subtracting. 125 minus 50. Okay, I want to hop down to example 3. You can see that we have a straight angle here. Angle DEF is a straight angle, or a straight line. So how far is it from here to here? 180 degrees. So what would angle X be? it would be 35 degrees. And if you wanted to set up an equation, this one's easy enough to do that you don't have to set up an equation. But if you wanted to set up an equation, you could go this little angle 145 plus this little angle x equals the whole big angle, and this whole big angle is 180 because it's a straight angle, a straight line. And then I could have solved this equation. Okay, number 4, we need to solve an equation. So here's my straight angle, my straight line. So how far is it from here to here? 180 degrees. So I know this little angle, 10x plus 30, plus this little angle, 9x minus 40, equals the whole big angle. And how much is the whole big angle? 180. And then I would just solve this equation. So what do? We can combine like terms. So 10x plus 9x makes 19x. How much does a positive 30 and a minus 40 make? A minus 10. Bring down the equals 180. Now to get x by itself, what do we do next? We get rid of the minus 10 by adding 10 to both sides. The 19x a drop, the equals a drop. How much is 180 plus 10? 190. And if I divide, what do I get? 10. Now that doesn't tell me what each of these angles are. I'd have to plug that 10 in to know how much the angles are, but all it asked me to do in the directions was to find the value of x. So I'm done there. Okay, we are going to skip some of these examples just because there's a lot of vocabulary and I don't want this video to take forever. So let's move to the next vocabulary word, and that is the word adjacent. Two angles are adjacent if they share a common side and a common vertex, but no common interior points. So here's angle 3, here's angle 4. You can see that they share this common side, and this is their common vertex. Angle 3's vertex is right here. Angle 4's vertex is right there, so they have a common vertex and they share this side. You can also see that these two angles, that they would add to be smaller than 90 degrees, so they both are acute. Both of those angles are acute, and they're also adjacent. Just extra terminology there. Looking at this picture, angle 1 is right here. So angle 1's vertex is right here. Here's angle 2, and you can see that angle 2's vertex is also right here. So you can see they have a common vertex, and they have this common side right here. So these guys are adjacent as well. Angle 1 and angle 2, they're special. They have lots of names. They're also called a linear pair because they form this straight line, this straight angle. So not only are they adjacent, but they are also a linear pair. And there's something else. If it's 180 degrees from here to here, that means that these two angles will add to be 180, and there's a word for that, supplementary. Two angles that have a sum of 180 degrees are supplementary. So they are also supplementary. Just abbreviate for right now. Okay, let's practice the word adjacent for just a little bit. Now in your life, you may hear the word adjacent used as the neighbor adjacent to me is my best friend. And that means the neighbor right next to you. So in math class and geometry, adjacent refers to two angles that have a common side and a common vertex. Okay, so we're going to pick from only adjacent, adjacent and form a linear pair, or not adjacent at all. So let's look. Number 1 says angle 1 and angle 2. So I'm only going to color part of the angle. Here's angle 1, and I know it's actually this whole big angle here. I'm just going to color part of it. So here's angle 1. Angle 2 is this whole big guy. I'm only going to color part of it. Do those two angles look like they are adjacent? Yes, they have a common side and here's their common vertex. Angle 2 and angle 1 have the same vertex and they share this common side. So yes, they're adjacent. Do these two angles make a whole straight line? No, so they're not a linear pair. So they are only adjacent. Okay, number 2 talks about angle 2 and angle 4. So let's look. Angle 2 is right here. And let's look where angle 4 is. Angle 4 is right here. Do these two angles look like they're adjacent? No, they don't share a common vertex. Angle 2's vertex is right here. Angle 4's vertex is right here. They don't have the same vertex, so these are not adjacent. So if they're not adjacent, there's no way they can form a linear pair. Okay, and number 3 talks about angle 1, which is right here, and angle 3, which is right here. Do angle 3 and angle 1 look like they are adjacent? Yes, they have this common vertex and they have this common side. Do angle 3 and angle 1, do they make a straight line when put together? Yep, from here to here, that's 180 degrees. So angle 1 and angle 3, they are adjacent and they form a linear pair. Okay. And these two words you should have seen in your past somewhere. So just going over those just a little bit. Complementary angles. These are two angles that have a sum of 90. Two angles that add to be 90. A minute ago we talked about if you see the little right angle box, you know that this is a 90-degree angle. But if I'm just talking about this angle alone, I can't say it's complementary because it's just one angle that's 90. But if you have two angles that add to be 90, those are complementary. So right here, you can see this right angle, and I know it's a right angle because of the right angle box, and it's made up of these two angles. So these two angles, angle 2 and angle 1, those will add to be 90, so that means that angle 1 and angle 2 are complementary. Okay, supplementary, we talked about that just a little bit ago. These are two angles that have a sum of 180. And you can see angle 3 and angle 4, those have a sum of 180 because from here to here, that makes up 180 degrees. So angle 3 and angle 4 are supplementary. Do you see any other angles in the picture that are supplementary? Angle 4 and angle 5 are supplementary because here's my straight line, my straight angle, and I know from here to here, that's 180 degrees. So angle 4 and angle 5 are also supplementary. And to practice our vocabulary from up above, angle 4 and angle 5, they're a linear pair because they make that straight line. They're also adjacent because they have a common side and a common vertex. Okay, skipping the next couple examples, I'm going to go to our last vocab word of this lesson, and that's vertical angles. So this is the way I like to explain it. If you have lines that make an X, vertical angles are the ones across from each other. These two angles right here, they're vertical. This angle right here and this angle right here, they're vertical. They're across from each other when two lines form an X. And one thing that's special about vertical angles is that vertical angles are always congruent. We will use this over and over and over again within this class. So whenever you have lines that form an X, angles across from each other are vertical, so they're congruent. Angles across from each other are vertical, so they're congruent. So let me show you a little example real quick. Let's say that this angle right here is 30 degrees. So this one would be 30 degrees because these are vertical angles. They're across from each other. Now, do you know how much this angle right here should be? It should be 150. See how we have a straight line? I know from here to here it's 180. Anytime you have a straight angle, a straight line. So that means that these two are both 150 because they're vertical angles. They're across from each other. Okay, so in this picture, angle 3 and angle 5, those are vertical angles because they form the X and they're across from each other. So those two angles would be congruent. Sometimes students think that angle 1 and angle 4 are vertical, but if you look at angle 1 and angle 4, they don't make that perfect X. So angle 1 and angle 4, those are not vertical. Okay, we have a ton of examples, and I am going to pretty much just save all of these examples for when I see you in class to make sure that you understand the vocabulary, and then we'll use that vocabulary to actually practice some concrete examples. So I'm going to stop here. Smiley face.